This video is on valence electrons. Only certain electrons, called valence electrons, determine the chemical properties of an element. Valence electron are the electrons in the atom's outermost orbitals, generally those orbitals that are associated with the atom's highest principal energy level, shell that's furthest away from the nucleus. For example, sulfur contains 16 electrons. So let's do an off-ball diagram to find out how many of those electrons are in its outermost orbitals. So sulfur has 16. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So its outermost orbitals are those of the third energy level. So we have electrons in the 3s and we also have electrons in the 3p. So if we count those up, 1, 2, 3, 4, 5, 6. And if we write out the configuration, we would have this, 1s2, 2s2, 2p6, 3s2, 3p4. So you could look at the electrons that are in the boxes, or you could look at the configuration and see that your highest number here is 3. But you can't just say 3p, okay, it has 4. It's all of the third shell here, which includes both the s and the p. So sulfur has 6 valence electrons. Let me show you a shorthand way of writing sulfur, or any element on the table's configuration. So if you were writing an element, you can put in parentheses or brackets the noble gas that comes before the element. So the noble gas in group 18 that comes before sulfur is neon. So in brackets, in neon means you have all of the electrons that neon has, the 1s2, the 2s2, the 2p6, all 10 electrons that neon has. And then you just write the electrons that are in sulfur that neon doesn't have, which would be the 3s2 and the 3p4. We'll practice more with this shorthand later in class. So anyway, there are the valence electrons. We have 6 total valence electrons. But you probably don't want to do an off-ball diagram every single time you want to determine the number of valence electrons. Cesium, for example, contains 55 electrons. And you could put 55 arrows in a box, but you'd get pretty sick of it after doing something like that. But if you did that, you would see that it only has 1 valence electron. Cesium's configuration in shorthand would be this. It has everything xenon has, plus it has 1 electron in the 6s sublevel. So francium, which is in the same group, has even more electrons than cesium, but it also has 1 electron in the 7th energy level. So I hope you can see the pattern here. If here's cesium and it has 1, and then here's francium and it has 1, everything in group 1 actually has 1. So that's a very easy way to determine how many valence electrons you have. Guess how many are in group 2? 2. Then we're going to skip the 13. Group 13 all have 3. 14 has 4. 15 has 5. 16 has 6. 17 has 7. And almost all of 18 have 8. So notice the box doesn't go around helium, of course, because helium only has 2 electrons total, and they're both valence electrons. Okay, so you notice I skipped the transition metals, 3 through 12. How many do they have? Well, it depends. Some of them have 1, some of them have 2, some of them might have a different number. So the way you're going to tell is not from the position number, and you don't need to do an off-ball diagram. You could if you want. But the way you can tell is by looking in the lower left-hand corner of the elements box on the table. So if you look in the lower left-hand corner, you see a series of numbers. 2, 8, 18, it's getting cut off, I can't read it, 18, 1 for silver. So all you need to do is look in the lower left-hand corner and look at the last number. So silver has 1. Cadmium has 2. That last number is the last electrons in the outermost shell. They're valence electrons in its valence shell. So, in summary here, you should know 3 ways to determine an element's number of valence electrons. You either get this from the off-ball diagram, which isn't hard to do, but it can be time-consuming, and you may not always have blank diagrams on tests to use. Like I said, these are training wheels that I will eventually take away. You could also note its position on the table, group 1, 2, and 13 through 18. It's very easy to determine how many valence electrons you have. Or, of course, you could look at its shell notation on the periodic table. And you could do that for any element, but you have to do that for elements that are in the transition metal land. So that's valence electrons. That's how you find them. This is a skill that's going to be very important that you'll be needing in other aspects of this course.